Hello everyone, welcome to another video. We will be discussing more questions on electromagnetic waves. We did some questions in the previous class. This will be the continuation of that video. So the first question is, suppose that the electric field of an electromagnetic wave in vacuum is E is equal to 3 Newton per Coulomb cos 1.8 radian per meter y and this T I can. So this is the electric field is given. Electric field is given. You don't need to write it again. Okay, just and from the you just write the values that are given. Okay, what is this? First of all, this is your E naught, amplitude of electric field is 3 Newton per Coulomb. And cos what is actually the electric field? E is equal to E naught cos omega t minus kx, right? And this is the direction of electric field. And this is suppose this is kx, so here it is ky, okay, ky, and this is I cap here. That means the direction of electric field is in the along x direction. But there is a plus here in between. So that means Amber. So, and there is a plus sign. That means I've told you if this is plus, then the direction of propagation of the whole wave will be in the negative of this one. I have negative j cap. Okay, all right. So you can write s vector is equal to minus j cap. E vector is along positive I cap. So we know s vector is equal to E cross B. Right, s is your minus j is equal to I cap cross something. So what I will multiply on I, that I will get minus j. It will be k, of course, because k cross I is actually j. So I cross k will be what? I cross k will be your minus j, right? So I cross and this will be k cap. So the direction of magnetic field is k cap along k cap. Okay, what is the magnitude or amplitude of a magnetic field? Okay, that will be B naught is equal to E naught. Okay, B naught is equal to E naught by C, right? Amplitude of electric field by C, speed of light, that is 3 by 3 into 10 to the power 8, that is 10 to the minus 8, and it will be Tesla. Okay, it will be Tesla. So this is a B naught, right? This is a B naught. Okay, this is a B naught, and yeah, write an expression for magnetic. So B we can write simply. We can write B is equal to B naught, that is 10 to the minus 8 cos as it is. Whatever there is inside, you just copy it down. But the direction of the magnetic field will be minus j cap, right? So this is minus here, and this will be j cap, minus j. Okay? Sorry, no. This is k cap, not k cap, sorry. K cap. This plus here. K cap. Okay? So this is a magnetic expression of magnet. What is the amplitude of the magnetic field of the wave? Amplitude means B naught. We just calculated it. 10 to the minus 8 Tesla. Okay, this is also done. What is the frequency f? F is equal to what? F is equal to omega by 2 pi. Okay, omega is how much? Omega t. So omega is your 5.4 into 10 to the minus 10 to the 6 divided by 2 pi. 2 into 3.14. Okay, if you calculate it, you will get your frequency. And what is lambda? Lambda is a what? Okay, we know wave vector k is equal to 2 pi by lambda. So lambda can be 2 pi by k. Okay, so 2 pi by what is k? Kx, that is ky 1.8. Okay, you will get lambda from here. Then it's in meter. So k is in radian per meter. So this would be in meter. Okay. Next, what is the direction of propagation of the wave? Direction of propagation is along minus j cap. That is along negative y direction, because your this will give me the direction of propagation y. Y means your j cap, but this is plus here. That means it's negative j. Okay. Yeah. So please write it down and please solve this. I have left it for you. Please solve it. Try to get the answer for it. This one, this one. Okay. Please finish it. Okay, we'll move to the next question. That is, these are MCQs. Okay, so we'll try them. Please try first. One requires 11 electron volt of energy. Uh, 11 volts of energy uh, to dissociate a carbon monoxide molecule into carbon and oxygen atoms. The minimum frequency of the appropriate electromagnetic radiation to achieve the dissociation lies in visible region, infrared region, ultraviolet region, microwave region. Please try. Easy question. You need to remember the wavelength. So please try. 11 electron volt of energy to dissociate a carbon monoxide molecule into carbon and oxygen. So, minimum frequency of the appropriate electromagnetic radiation to achieve the dissociation. That means the energy must be the minimum energy is this much. So, which radiation has this much energy? That one you have to remember. That is your UV region. Okay, UV region has energy as 11 electron volt. You have to remember this. So, 11 electron volt lies in UV range. Okay. Otherwise, don't need to remember the values. Like you just remember the frequencies of UV, frequency of UV, okay, or wavelength. Anything you remember, and from that, what you can do, you can put Hc by lambda or H nu and get the energy and match it with this. Okay, yeah. Okay. Next question. If E and B represent electric and magnetic field vectors of electromagnetic wave, hmm, then the direction of propagation of electromagnetic wave is along. If E and B represent electric and magnetic field vectors of the electromagnetic waves, the direction of propagation of electromagnetic wave is along. Tell me, this is very simple. I've written it again and again. S vector, pointing vector is equal to E cross B. And this pointing vector is actually what? Your direction of propagation of electromagnetic wave. Direction of propagation of EM wave. Okay, direction of propagation of EM wave. So this is actually the cross product of electric field and magnetic field. Suppose electric field is along I cap, magnetic field along J cap. So the A vector will be perpendicular to both electric and magnetic field, that is along K cap. Because we know if A vector is equal to B cross C, hmm, then A is perpendicular to both B and C. If you see, this is your electromagnetic wave. This is like this. Suppose this is your electric field. This is your magnetic field. So the whole thing is moving along x-axis, the whole wave, and your this magnetic field is along z-axis, and this electric field is along y-axis. Okay, so yeah, you can see y cross z is equal to x. Okay, yeah. Please try next question. Hello. Okay. No data. I mean, data. Into ଜଣେଇବୁ ଗୋଟେ ଭିଡ଼ିଓ କରୁଛି ମୁଁ ଜଣେଇବୁ the ratio of contributions made by the electric and magnetic field components to the intensity of an electromagnetic wave is. Please try this question. Ratio of contributions made by the electric and magnetic field Components to the intensity of an electromagnetic wave. Yeah, please try. What is the intensity amplitude relation? Think through that. You can think that way. Intensity is an amplitude proportional to amplitude square. Okay. So that means intensity of electromagnetic wave, right, will be what? Amplitude square. Ratio contribution made by electric field to the intensity of electromagnetic wave. Okay. Intensity of E electric field is proportional to amplitude of electric field square. Intensity of magnetic field proportional to amplitude of magnetic field square. Ratio contributions made by to the components of intensity of an electromagnetic wave. Okay, we know E naught by B naught is equal to C. How much we know. See contribution made by electric and magnetic field components to the intensity of an electromagnetic wave. I'm not sure about this one. This intensity of electromagnetic wave. I know. This ratio contributions to the intensity of electromagnetic wave. Okay. Okay. So intensity of electromagnetic wave is proportional to this. So the ratio if I take E square by B square is equal to I by I, that is 1. Maybe this way, I think. Because intensity of electromagnetic wave is directly proportional to amplitude of like electric field square, amplitude of magnetic field square. If I take the ratio, it's the same thing. It's I. So I by I that is 1:1. This I'm not sure about this. Okay. Maybe. Next question. Just try this one. Light with the energy flux 20 watt per centimeter square, it falls on a non-reflecting surface at normal incidence. The surface area has an area of 30 centimeters square. Total momentum delivered during 30 minutes. Okay, exactly this type of question we did yesterday, so please try. Exactly this exactly like energy flux was given, E was given, area was given, and I solved it yesterday, so please try this question. Energy flux from unit, what can you guess? 20 watt per centimeter square. That means it's kind of power by area. This is your area is given 30 centimeters square. So if I multiply these two, power by area into area, I will get power, right? So power is equal to energy flux into area. 20 into 30, 600 watt. Okay, you can tell me, sir, I could have converted into meter square. No need, because this is centimeter square, this is centimeter square. So if I write it properly, it's like this only. Centimeter square eventually cancel each other. So it's 600 watt. So power is 600 watt. Okay. You have time. Time is equal to 30 minutes. Hmm. Time is equal to 30 minutes. And power into time is your energy. Energy is, I will write it simply, that is power, sorry, power into time, that is 600 watt into 30 minutes, that is 30 into 60 seconds. So this is your 18, how much, 18, 6, 128, 128, 000, okay, 30 gram, 4 zeros, right? So this is your energy, this is in joule, right? 18.6, oh sorry, 108, sorry, 1.08 into 1, 2, so 10 to the power 6 joules, right? This is energy is this much. What is our total momentum to do? Okay, this is a non-reflecting surface. Okay, for a non-reflecting surface, non-reflecting surface, I told you yesterday, non-reflecting surface, your momentum is energy by c, speed of velocity. For a perfectly reflecting surface, perfectly reflecting surface, your momentum is 2e by c. Okay, so this one is non-reflective, so e by c, e is 1.08 10 to the power 6 divided by 3 into 10 to the power 8. Okay, so if I do this, 3, this is 6, okay, into 10 to the power minus 2, so 3.6 into 10 to the power minus 3, and momentum is your kg into meter per second, because momentum is your mv, mass into velocity, mass is kg, velocity meter per second. So 3.6 10 to the minus 3. Yeah. 3.6 10 to the minus 3 can be written as 36 10 to the minus 4. Okay. So the option B is correct. So that's correct. Okay. Let's move to the next question. Right. Again, same kind of question. So I will not repeat it. You please try it, do yourself. Yep. 2 minutes. Plane electromagnetic wave. The electrical oscillates sinusoidally at a frequency of this. What is the wavelength of the wave? Amplitude of the oscillating magnetic field so that the average energy density of the electric field equals the average energy density of the magnetic field. Let's try. Frequency frequency is given 2 into 10 to the power 10 hertz. Amplitude is given 48 volt per meter. Okay. So electric field oscillates. Okay, electric field has amplitude. So E naught. What is the wavelength of the wave? Wavelength is what? 2 pi by k. Okay. Okay. Let's try this one. K is omega by c, isn't it? Right. Omega is a 2 pi f, 2 pi nu by c. Yeah. K is equal to 2 pi nu by c. So 2 pi into 2 into 10 to the power 10 by c. C is 3 into 10 to the power 8. From there you can get k. Okay. If you put k here, 2 pi by, just put it here. This is how much? 10 to the power 10 na? This is 10 to the power 2. So 2 pi into 2 into 10 to the power 2, 3 goes up, right? 2 pi cancel out, 3 by 2, 1.5 into 10 to the minus 2. So this is in meter, right? So lambda is 1.5 into 10 to the minus 2 meter. That's all. What is the amplitude of the oscillating magnetic field? We know again B naught is equal to E naught by C. Very easy. So 48 by 3 into 10 to the power 8. Okay. So 16 into 10 to the minus 8. That is Tesla. This is gone. So that the average energy density of the electric field equals the average energy density of the magnetic field. This is a proof, so we don't need to do it. We won't have proofs in exam. So let's leave it. No problem. Okay. Next question. Okay. The charge on a parallel plate capacitor varies as Q is equal to Q naught cos 2 pi ft. The plates are very large and close together. Okay. Neglecting the edge effects, find the displacement current through the capacitor. Okay, please try this question. Displacement current is asked. So please try. Here we can directly put ID is equal to ID is equal to IC. Displacement current is equal to conduction current. Okay. So is equal to dq by dt. Okay. So d by dt of q naught cos 2 pi ft. Alright. So q naught goes out, cos 2 pi ft, that is minus sine 2 pi ft into 2 pi f. Right. That's it. That's also minus 2 pi f q naught sine 2 pi ft. Okay. Yeah. Is it clear? Okay. So these are some of the questions from I think wait, no, there are more questions. Yeah. More than one correct option. These are called MSQs. Okay. Multiple select questions. That means more than one option will be correct in this type of question. So like these questions, if there are two correct answers, two options A and C, we have to tick both of them to get the full mark. If you tick only one, you won't get half mark. You will just get zero. Okay. So, yeah. A plane electromagnetic wave propagating along x direction can have the following pairs of EB. Okay, let's try this question. Easy questions, don't leave them. Plane electromagnetic wave propagating along the x direction can have the following pairs. That means what is given exactly? S vector is given, right? S vector is given, like the whole electromagnetic wave is S vector, pointing vector, given x direction. That is, this is along I cap, and we know x vector is equal to E cross B. So how will I arrange your E and B so that I will get I? That is the question only. So please try. Okay. See, how will I get I? Only if there is Y and Z here, right? If there is J and K in any kind of order, then only I will get I. I cannot get I from I and K, or I or J or I, right? So if I is present in these two, I will not get I. It should be different than I. J, K, that is cross product, na? That's why. So K cross J, K cross J is your minus I cap. So it's like long H direction means what? Means it can be negative x or positive x. Okay, and this is also a MSQ question, so more than one option correct. So we will have to assume that this is minus x and positive x. So k cross j is minus I, j cross k is I, right? So both are correct. So k, j and jk present. Where k means z axis, y, j means y axis. So z, y, y, z. See, y, z, z, y. These two are correct. These two are wrong because x is present here and we cannot have x and this side to get a dot product x on the other side. Okay. Yeah. Next question. The source of electromagnetic waves can be a charge dash. Right? Yeah, 1 minute. Think a bit about it. Don't rush. Think a bit. See the options. The source of electromagnetic waves can be a charge. Okay. Moving with constant velocity, moving in a circular orbit at rest, falling in an electric field. Which one can be your answer? See, when charge oscillates, it creates electromagnetic wave, right? So, moving with a constant velocity cannot be the answer because it's not constant velocity. If it is moving with constant velocity, then there is no change, so that it won't produce any disturbance, any electromagnetic. At rest, this is not at rest. We know it. So these two options are gone. Moving in a circular orbit, yeah. Moving in a circular orbit is like there is change of velocity, right? In every point, speed is constant, but velocity is different. Direction is different. That means what? That means acceleration is there, and that means an electromagnetic wave can be produced. This can be a source of electromagnetic wave. Falling in an electric field, yeah, falling in an electric field can also be a source of electromagnetic wave. Okay. So these two are the correct options. Option B, option. Okay. An electromagnetic wave intensity I falls on a surface kept in vacuum exert radiation pressure P unit, which is the following are true. See, this is I have done it told it yesterday. If it is totally reflected, what is it? The pressure is 2I by C. Okay, so option C is correct. If it is totally absorbed, yeah, that is your radiation pressure is how much? Is A by is I by C. Okay, also write it down. Okay, concepts. And radiation pressure is I by C if it is totally reflected. No, this is wrong because option C and uh, between option B and C, C is correct. Radiation pressure is in the range this for real surface. Yeah, you can see I by C to 2I by C. So, yeah, for real surface. Yeah. So this is it. Okay. Next, charged particle oscillates about its mean equilibrium position with a frequency of 10 to the power 9 hertz. Okay. The electron wave produced. Just have to try get the values. You have new. Okay. See, frequency is 10 to the power 9. That means the electromagnetic wave will also have a frequency 10 to the power 9, right? Hmm. It won't have the different frequency. They have the same frequency as the particle. Okay. EM wave frequency, same frequency as the charged particle. Okay, yeah. The electromagnetic waves produced, yeah, we'll have a wavelength. Wavelength we have to check. If you have nu is equal to c by lambda. You can check from there. Lambda is equal to c by nu. Okay, 300 over 8 divided by nu, that is 10 over 9. So 300 over minus 1, that is 0.3 or meter, right? Lambda is 0.3 meter. Yeah, this is correct. Fall in the region of radio waves. Yeah, if your nu is your this one 10 to the power 9, it is in the radio wave region. Okay, so just you have to again remember the regions, right? And see another from where you can guess 0.3 meter is a big wavelength. It's coming in meter. Usually it's in micrometer or like those things, but it's a meter. That means it's a big wave, and which is the highest, which is the wave having the highest wavelength. That is radio wave. So from that you can guess this is a radio wave. Okay, yeah, in that way also. I think yeah, this much should be there for this class. I hope you understood. Any doubts, you please let me know in the comments. Okay, and that will be it for this class. Thank you very much.